So this is MYP4 Unit 3 Chapter 2, and it's a revision of standard form which you've seen earlier in the MYP program, also known as scientific notation, or it's got a Danish name, Den Videnskabelige Skrivemåde. I always have trouble saying that. Literally the scientific way of writing. And it's a way of writing the very large numbers, like the distance to the sun, or the very small numbers, like the diameter of an electron, for example, that you see in science. And the point is, these very big or very small numbers have lots of zeros in them, and that's very inconvenient to have to write all those zeros. So it's a way of writing those very big or small numbers without having to write all the zeros. So I have a particular way of setting these out. So this is the distance to the sun. So it's a 149, then loads of zeros, and then directly underneath it I've written a 1 with lots of zeros filling up the same space. And then from the 149, from those digits, I've got my number between 1 and 10. So my number between 1 and 10 is 1.49. So the number that I've got here, which is 14,900,000,000, can be written as 1.49 times and then a 1 with all these zeros. And you can get the number of zeros right just by lining up the zeros and the number when you write it, because with all the columns lined up like that, you can kind of see that the number here with all the zeros multiplied by 1.49 I should say, gives you a number that's still got a 1 in the same place, but then the 49 after that. You can kind of see by lining it up that it's 1.49 times as big. And that number has got 10 zeros in it, so that's another way of writing that is 10 to the power of 10. So that number is 1.49 times 10 to the power of 10. And that's in standard form, because standard form involves writing a number as something between 1 and 10 multiplied by 10 to the power of something. So the takeaway from this is the method of writing things lined up so that you get the right number of zeros in the number. Because you might have looked at the original number with only 8 zeros and then thought that the final thing should have 10 to the power of 8. But then writing it lined up like that, you can see that you're getting another couple of zeros in the spaces taken up by the 4 and the 9. So this lining it up is very important to setting it up, or setting it out, I should say. So here's an example with a very small number. So 0.000000316. So I need to think of a number from those digits that's between 1 and 10. So that's 3.16. And then I've got to multiply by a number that is lots of zeros and a 1 on the end. And again, by lining it up here, a 0 there and a 0 there, zeros there and there, zeros, 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 zeros. But then you finally get to the first digit of the 316, and then you put a 1 underneath that first digit. Then hopefully by lining it up like that, you can see that the number here, 0.000000316, is 3 and a bit times as big as the number underneath it, 0.0000001. You can kind of see that the number above is about 3 times as big as the number underneath, because it's got a 3 in that particular column instead of a 1. And of course the common mistake would be to write zeros all the way till the end of the number and then a 1 underneath the 6 here. But if you did that, then the number above would be not 3.16 times as big, but 316 times as big. So again, this idea of keeping the thing lined up, and you can see that the number above is about 3 times as big as the number below. Okay, so the number I started with equals 3.16 times 0.0000001, and that number has 7 zeros in it, including the one before the decimal. So another way of writing that, as we saw earlier in the MYP program, is 3.16 times 10 to the power of minus 7. There's always a link between the number of zeros and the power number. So 7 zeros in the number is telling you, for a very small number, that it's 10 to the power of minus 7. You can go back to the previous unit where you first encountered standard form if you want a fuller revision of that. So here are some questions that we did in class. Pause the video, have a go at those questions. So it's got a big number that you've got to write in standard form, a small number that you've got to write in standard form, a big number in standard form that you've got to put into ordinary form, and then the same with a small number. So pause the video and have a go at those. So here come the answers. I hope you paused the video. So 634,000, 634,000. So from that, I've thought of a number between 1 and 10, which is 6.34. And then underneath it, I've written a number that's a 1 with lots of zeros. And by writing the 1 underneath the 6, I can see that that number there times about 6 gives me the number above. And that number there has got 5 zeros in it, so it's 10 to the power of 5. So the final answer is 6.34 times 10 to the power of 5. Next one. So 0.0076. My number between 1 and 10 from those digits is 7.6. And then underneath it, I'm writing a number that's lots of zeros followed by a 1. So 0.001, and then you can see that the first, the one that I've written is underneath the 7, that's the first significant digit in the number. And by writing it underneath like that, I can see that it's about 7 times as big. And again, the mistake would be to slip an extra 0 in there and have the 1 underneath the 6 and have a number that's 76 times as big. But that would be wrong because it's only wanting to be 7.6 times as big. Okay, so 7.6 times 0.001 is the same as 7.6 times 10 to the power of minus 3, because that number's got 3 zeros in it, including the one before the decimal. So the final answer, 7.6 times 10 to the power of minus 3. Next one, 7.62 times 10 to the power of 5. I've written again as 7.62 times 100,000, a 1 with 5 zeros. And then turning that into an ordinary number, well, if it's 7 times as big as 100,000, then it ought to have a 7 in the first place instead of a 1. So 762,000. And again, writing the things in line helps you to see that the number is 7 times as big. And the mistake would be, the common mistake would be to write 762 and 5 zeros on the end, because you've got 5 zeros in the original power of 10. But hopefully by writing things in columns, you can see that that's right, and the number I've written as the final answer is indeed 7 and a bit times bigger than 100,000. So final answer, 762,762,000. And the next one, 3.12 times 10 to the power of minus 4. I've written as 3.12 times 0.0001. That's 4 zeros, including the one before the decimal. And then if you've got a 3 underneath the original 1, you can see that the number's about 3 times as big as the number above. So 0.000312, you can hopefully see that that's 3 times as big and a bit than 0.00001. So final answer, 0.000312, and writing things in columns like that helps you to get the right number of zeros and the decimal in the right place.